Hello, Bacho. Now we are providing the solution for the real number. That is the question belongs to NCRT book, and this is the solution. The first question we have here: express each number as a product of its prime factor. So when we are starting this chapter, we know that already you have the idea about prime factors, co-prime, other things. Okay, so prime number already you know what is the prime number. Prime number that is starting with they have the factor one and itself number itself. Suppose example we have 2, 3, 5, 7, 11. These all are the example for prime factors. So when you have to do the factors, you have to use the prime numbers only. I have seen many children when they will do the factorization, they will start with any large number also, any number, but they have to start with prime number only. Suppose here we have the one example here. First question. So example like first A we have express each number as a product of its prime factor. What we have 140. So what you have to 140? How can you factorize as a prime factor? Suppose 140 we have here. How can we do? Here 140, how can you do? Suppose we have, so you have to remember we have to start with prime number only. How can prime number? So starting with 2, 2 7 ja and 0, correct? Now again you do with 2, what will get? 2 3 ja 6 and 2 5 ja 10. Again, now which table 35 will come, and that should be also the prime number. So we can start with 5. So what you can say? 5 7 ja. What you can say? 5 7 and 7 1 ja. So what is the prime factor? You can write here now 2 into 2 into 5 into 7. So this is the prime factor for 140, correct? Now for B question, what the B we have? 156. We have 156. So we have, I forget to say, 156. The question we have 156. So I am writing the question here 156. How can you do 156? Same method you have to apply. How we have to utilize same method 156. So write 156. Always remember start with prime factor. So what you can say? 2 7 ja 14 and 1 and 6 2 8 ja 16. Now what you can write here? 2 3 ja 6 and 2 9 ja. Now you can say which table 39 will come? 13. 13 3 ja this one. So what you can write here? Now you can write here 2 into 2 into 13 into 3. This is the prime factorization of 156. Now we have another question. What we have? We have another question. We have 3825. What you have? 3825. The question we have 3825. So how can I write 3825? C. What you have? 3825. 3825. So we can write 3825. How can we do prime factorization for 3825? That also we can start. So 3825. You can start with 3 tables. So how can you say 3? 3 1 ja 1, 3 2 ja 6. How much? 2 and 2 22. 3 7 ja and 1 3 15 ja. Correct? You do with again 3 only start. 3 4 ja and 3 2 ja 6, 3 5 ja. Now we can start with which table? Now we can start with 5. How you can start with 5? So 5 8 is a 40 and 2 5 5 ja. Now again you do 5. What will get beta by? 5 7 ja, 5 1 ja and 5 2. So 5 7 ja and 17. You can say it is 17 1 only. What is the answer should be there? Prime factorization we can write beta here. 3 into 5, 3 into 5 into 5 into 17. So this is the prime factorization for this question. Now what you have beta? Another question we have. Another we have 50 not 5. So what we have? 50 5005. What you have to write? 5005. D question we have 5005. Correct? D question we have 5005. This also how can you do? We have to do same prime factorization method. How? So please start with the solution. We have 5005. You start with prime number 5 only. Correct? How can you find? So 5 10 ja 0, 5 1 ja. This you can say. Now what you can say? Now you can start with 7. Correct? 7, because you see, you have to remember 5 table will not come one last. Any 5 table you start, any till 11, anywhere you go, you won't find 1 is the last number. So you have to think either it will come in 3, 3 7 ja, 21, 7 3 ja, 9 9 ja, 81, like that. So here we have to start with 7. So what you can say? 7 1 ja 1, 3 and 0, 7 4 ja 28, and it will be 2 and 1. So 21 7 3 ja. Now we have to start with 11. Just to do better, 11, how can you say? 11 1 ja 11. Now you will get 3 and 3 33. So 11 3 ja 13. Now 13 into 1. So you get 31 ja 1. So what is the prime factorization for this? You have to write the solution 5 into 7 into 11 into 13. This we got the prime factorization for 5005. Now another question we have E. What we have another question? We have 7429. 7429. What you have? 7429. There we have to do the prime factorization. How can you do the prime factorization for this? This also we can start. This little, if you are good in the table, then factorization will be very simple for you. If you are not okay with tables, then gone. We are teaching many students since from the beginning. We used to say, please have the table properly, please have the table proper. They are not understanding. They are thinking, sir, now in the 10th standard, 9th standard, I have to remember these tables. Yeah, it is. If your table is fine, your calculation will be smooth, your calculation will be fast. Otherwise you have to struggle, you have to multiply everything, you have to multiply and think. So efficiency will be reduced. So please remember, table should be 100% perfect. You have to remember all the tables, at least minimum 20, 2 to 20. You have to practice every time, so you will have the easy things, easy and fast calculation. Now I am doing for this 7429. How can you do this? This you can start now. 7429. I am starting here. We can start with directly. We can start with here 17. So how? 17 also prime number. You have to remember 17 also a prime number. Correct? So 7 4 ja. How much? 7 4 ja 68. 7 4 ja 68. Now tell me, how much it happened? 674 and 68 minus. How much it will be? 6 and 6 2. How much it will come? 17 4 ja 60 68. So it will be 6 and 2. Again you have to do this one. 68 only. 62. So 17 3 ja. You do 3 ja. So what you had here, you remember 17 4 ja 68. If you had a 6 and 2. 3. So 62, we had 62 and minus 51. So what you can say? Minus 51, you can say 51 only. Correct. 51 only. Then you will get 62 and 11. And 11 and 9. 17 7 ja 19. Correct. This we had. Yeah. Now you have to do 19. What you have to do better? With 19. 19 start. 19 3 ja 19 2 ja, correct. 19 2 ja 38. Now 5 and 7. So 19 3 ja 57, correct. Now what you have to use? 23 into 23 only. So you can say 23 1 ja. So what your answer should be there? Your answer is 17, 19 and 23. This is the prime factorization we did. Now we have the second question. What is the second question we have? Second we have find the LCM. Find the LCM and HCF of the following pairs by prime factorization method. So what you have? So prime factorization method. So what is the first question we have? 12 and 16. So second A, we have to write second A question. What we have? Second A question we have. Second A we have 12 and 16. What they are asking? They are asking find the LCM and SCF of the following pairs by prime factorization method. So A we have, B question we have 336, 12, 6, 336 and 54. Now we are starting with prime factorization. Again, we have to do prime factorization. This I think it's very simple, yeah, but many students doesn't know because their basic is not poor. Math is 100% basic. If your basic calculation, basic mathematics is fine, you will be very happy to solve the question. Otherwise, you have to struggle a lot. Correct? So my children's, please focus on the basic. While summer vacation, while you have the rest period, that time please learn basic mathematics. Don't hesitate to learn, otherwise you have to struggle whole life. Correct. Now you come for prime factorization on the topic. What is the topic? Prime factorization. So now you do 12. What is the 12? We have to do prime factorization. What you can say? 2 6 ja, 2 3 ja, and 3 1 ja. So what is this prime factorization we got for this? We got 2 into 2 into 3. This we got. Now we have to go for 16. How we can do for 16? You see 2 8 ja, 2 4 ja, correct. Now you have to do 2 2 ja. Now you have to do 2. Now you see what you can write for this. We can write for this 2 into 2 into 2 into 2. You see, how can you say highest common factor? You see, which is available in both. You see, the number which is available in both, minimum number which is available in both. You see, 2 2 here we have, and 2 2 here also we have, correct? So, what is available in both? These two and these 2 2 available here. So, what you can say? What is SCF? SCF you can write 2 into 2. It means what you can say here? SCF will be 4. SCF is 4, and you have to find LCM. LCM, how can you find? So highest degree available in both. So what is the highest degree available in both? What is the highest degree we can say here? You see here. So what is the highest degree we have? 2 to the power 4 we have. Here you can write 2 to the power 4. Here what you can write? 2 to the power 2 into 3 we can say. Correct. So 2 to the power available here and 3 also available here. So that we can write here. What is LCM? We can write here 2 to the power 4 into 3. So LCM, which is highest degree. So you see highest degree 2 to the power 4 we have, and this number 3 also in this part. So both multiply will be LCM. So LCM we can write, what you can write? LCM we can write 2 to the power 4 into 3. What is the answer? 2 2 ja 4, 2 ja 8, 2 ja 16. 16 into 3. You will get 16 into 3. You will get 48. So LCM we got 48. Correct? This is for A question. Now we have to do for B. What you have? B. 336 and 54. 336 and 54. How can you do? That also you try better. 336. 2 1 ja 1. 2 6 ja 12 and 1 and 2 8 ja, correct. Now 2 8 ja 16, 2 4 ja, now 2 4 ja and 2 2 ja, now 2 2 ja 2 1 ja, 3 7 ja and 7 1 ja, correct. So what we got here? We got their factor. What we got their factor? 2 into 2 into 2 into 2 into 3 into 7. This we got. Now we have to do for 54. 54 also try to do. How? You see 2 2 ja 4, 2 7 ja. Now we have to use 3. 3 9 ja. Now we have to use 3 3 ja and 3 1 ja. So what is we can write their factor? 2 into 3 into 3 into 3. You see what is the common in both? You can say 1 2 here also, here 1 2 here also. That is 1 for 2 part. Now 3 or 3 also here available and 1 3 also. So this 2 and 3. So SCF what you can write? SCF we can write. SCF we can take these 2 and these 2 and these 3, these 3. So you can say 2 into 3, and which is available again. So only D 2, 2, 3, 2, 3 and 2, 3. So 6 we can say this as a SCF. So SCF you can write 6. SCF will be 6. And LCM what you can write? LCM we can write what is the highest degree here you see? Here what is so this you can write here. Highest degree what you can say? 2 to the power 4. You see, na? In 2 how many 2 are there? So we have 4. So 2 to the power 4 into 3 into 7. And here what we have? 2 to the power 2 and 3 to the power 3. So you see what is the highest power we have? Everywhere what is the highest power we have? So highest power we have in this what you have highest power 2 to the power 4. Correct. Here what is the highest power we have for 3? 3 to the power 3, and you have to remember 7. 7 you have to write 7. Correct. 7. What you will get the answer? You will get the 7. You will get the answer if you multiply 2 2 ja 4, 2 ja 8, 2 ja 16. So 16 into 3 3 ja 9, 27 into 7. If you multiply, you all will get 3024. So this is the LCM. This is the LCM for this question. Correct. So second we have finished. Now we have come for. So now I am changing the page. Now we have to go for third question. What is the third question we have? Find the LCM of and SCF of the following pairs and verify the LCM into SCF is equal to product of the two numbers. Correct. So this is the question we have. Third. What they are asking? They are asking to find out the LCM and SCF of the following pairs. Correct. What is the pair? We have first pair we have 6 and 20. What you have? 6 and 20. What you have to find there? There you have to find the SCF and verify. Find the LCM and the SCF of the following pair. So first you have to find the LCM and SCF of this pair, and then you have to use the verify LCM into SCF is equal to product of the two numbers. That you have to find the solution. How can you find 6? So now you learn to already know LCF of the 6. How can you find LCF of the 6? 2 3 ja, correct. 3 we got. So what you can write here? 2 into 3. Correct, their factor. Now 20, how can you write? 20. 20 you can write 2 10 ja, 2 5 ja, and 5 1 ja. So how can you write here? 2 into 5, and here 2 into 3 already you have. So SCF is equal to what you can write? SCF is equal to we can write which is available in both. So 2 is available in both. So what you can say? 2 SCF. LCM what you can say? This you can write as a 2 to the power 2 into 5. And here what you can write? 2 into 3. So what is the highest power for 2? 2. So LCM what you can write? LCM we can write 2 to the power 2 into 5. Correct? So what we will get? 2 to the power 2 and so I think it is question we said wrong. We have question 12 and 16 only. No? 12 and 16. Correct. 12 and 16. 6 and 20. Correct. 6 and 20 we have. 6 and 20 we have. So what you can write LCM? You can write 2 to the power 2 into 5 into 3. Correct. So what we will get? 4 into 5 into 3. You will get 60. So we got SCF to LCM 60. Correct. So LCM how much you got? 60. SCF how much you got? 2. Now you remember that we have the one formula. What is the formula we have? Formula we have SCF into HCF. You have to remember. One marks they can ask in the exam. SCF into LCM is equal to what we have? Product of given two numbers. Correct. So now how can you do here? You have to remember here 2 into SCF how much you got? SCF already you know how much? 2. SCF we have 2. So you have to write SCF 2, LCM how much? 60, and product of two number what you have? Product of two number what you have? Product of two number is already in the given in the question. No, not given in the question. So what you can say, it will become 2 into 60. What you will get? You will get 120. 120. What you will get? 120. You got SCF. Now product of two numbers. So what you can say, product of two number, you see already verified na, product of two numbers. So what are the two number given? 6 and 2. 6 and 2 number, what you can say? 6 and 20. This you can write na, only one number we have in question, only we have na, 6 and 20. 6 and 20. So two number what you have? 6 and 20. What you got? 120. We got 120 and SCF. So this verified SCF into LCM. We got product of two numbers. What are the product of two product? What are the number? 6 and 20. So we got 6 and 20 as the product of two number 120 and 2 into 60. 2 was the SCF and LCM was 60. So this question we have finished. Now we have another question. We have another question. What you have? Another question we have. 336 and 54. So what you have to do? We have to do third B. Third B. What we have? Third B question. Third B question we have 336. I am writing now 336. 336 and 54. I have to write the question here. 336 and 54. What you have? 336 and 54. 336 and 54. Now we have to follow same thing. What you have to do here? So 336 and 54. How? We have to again do the prime factorization. Correct. So we have to do prime factorization. How can you do prime factorization? This you can do. How? You see. 2 1 ja 1, 2 6 ja 12 and 1 and 6 2 8 ja. Correct. Now you have to do 2 8 ja 2 4 ja. Now you have to do 2 4 ja 2 2 ja 2 2 ja 2 1 ja 3 7 ja. So what you got here? You can write here this as a 2 into 2 into 2 into 2 into 3 into 7. So you see how many 2 we have? You can write 2 to the power 4. For LCM I am writing like that. 2 to the power 4, 3 into 7. Correct? This we got. Now we have to do for 54. So what you have? 54. How you can do 54? 54 also do prime factorization. How? 2 2 ja 4, 2 7 ja and correct. 3 9 ja, 3 3 ja, 3 1 ja. So what you can write? We will write 2 into 3 into 3 into 3. This you can write as a 2 into 3 to the power 3. Now you have to remember for SCF what we are writing? For SCF we are writing, for SCF we are writing which is the highest common in both. So what is the highest common in both? You can say here also we have only 1 2 is here and we have many for 2, but you have to count only minimum number which is available in both. So 2 and 2. So first we write 2, correct. Now what you have write here? 3 also available here and 1 3 also here. So this also you write 3. Correct. Now I don't think anything is remaining here. So what should be the SCF for this? SCF you have to write here. This will be SCF. What is the SCF? This will be the 14. What is SCF? You can say 3 not 6 336. No? So SCF we got beta 6. LCM what you can write? LCM you have to take, already we have done the this one highest common, highest degree. What is the highest degree? 2 to the power 2, 2 to the power 3. So LCM we can write highest degree. What is the highest degree we have? 2 to the power 4. And here what you have? The highest degree for 3, 2 to the power 3. Correct? And we have one 7 number. So you write what you will get the answer. You will get the answer for this. You have to multiply. You have to do. How you will get? You do 2 to the 4. 2 to the power 4 means 2 to the 2, 4 to the 8 to the 16. So 16 into 2 to the power. Sorry, it is 3, no? 3, I wrote wrong. It should be 3 to the power 3. So you can say 3 to the power 3. So it will be 27 into 7. If you multiply, what you will get the answer? You will get answer 3 to the power 3. 3 to the power 3. If you multiply here, 7 7 ja 49, 7 7 ja 49, 4 7 2 ja 7 ja 49, 4, 7 2 ja 14, 14 and 4, 18, 1, correct, into 16, you do, then 6 9 ja 54, 5, 6 8 ja 48 and 5, 53, 3 5 6 5 11, so you get 1 9 8 and 1, you will 4 2 9 to 9 9 10 and 2 3, so you got 3024. So you see the product, what we said the product of two number. Now we got the LCM, so we got SCF and LCM. What we got? SCM and LCM. So once I am writing SCF, we got 6, LCM we got 3024. We got LCM 24. Now again you have to use verify. How you will verify? You already know the formula. What are the formula for this? We already said SCF into LCM is equal to product of two number. Product of two numbers, correct? Product of two number, what we had, you remember, we have 336 and 54, 330, 336 and 54, correct? And what is the SCF we got? 6 we got. LCM how much we got? 3024 you got, correct? Now if you verify, if you multiply 6 4 ja 24, 2 6 2 ja 12 and 2 14, 1 and 6 0, so 1 only, 3 6 3 ja 18, correct? 18,144 you got. Now again you multiply this 336 into 54. How? 6 4 ja 4 6 ja 24, 2 4 3 ja 12 and 2 14, 1 in hand, so 4 3 ja 12 and 1 13, correct? 5 6 ja 30, 3 5 3 ja 15, 3 18, 1 in hand. Now 5 3 ja 15 and 1 16, so what you can say? 4 4 18 11 1 7 1 8, so 18,000, you see 18,144, you see both verified. So what we said, SCF into LCM, the product of two number, it is verified. So product SCF how much you got? 6, LCM 3024, and product of two number 336 and 54 we got this. So this is verified. What you can say? This we verified. This question verified. Correct. Now we have third question. What you have third question? Sorry. Third one. We are doing third only. Third. 336 and 54. So what we did the wrong question. I think we have to find 6 and 20. After that we have to use 6 and 20. After that you have to use B question. B what you have? 306 and 657. So one more time I am doing for this question. Yeah. So how can you do 306? 306 and 65. 306 prime factorize, and how? 2 15 ja, 2 3 ja, 2 7 ja, oh sorry, you can't do with 3. 3 5 ja, 3 1 ja, 3 17 ja, 370 ja. So what you can say? And 17. What will you can write like 2 factor 2 into 3 into 3 into 17. What you will get here? If you multiply, what you will get? If you multiply all this, you will get 306. So this is the there. So you can write 2 into 3 square into 17. This is for why I am writing the power to for the LCM purpose. Now come for 657. So you write for 657. You see which table we can start 657. You see 7, no? So 7 we can start generally either 7 or 3 tables. So you can say 3 2 ja 6, 3 1 ja 1, 2 and 3 9 ja 7, 27. Correct. Now we have to start with 17 table. 657, no? 657. So you start with beta here. 3 again with 3 only. 3 7 ja, 3 3 ja. Correct. 73 table, we don't have any 73 table, so 73 directly. So what you will write here, beta? You can write 3 to the power 2 into 73. This is, so now we have to write SCF. How much you got? SCF means the minimum number. So 2 is not here available. So 3 square and 3 square here, 3 square means 3 into 3 into 3 is available in both. So what should do the SCF? So it means 3 square available here. So what you can say, SCF we can write, SCF we can write here 3 square, 3 into 3 means 9. SCF we got 9. LCM is equal to what you can write? LCM we can write here highest power. What is the highest power for 3? So highest power for 3 to the power 3 to the power 2, and 2 is remaining, and 17 also there, and 73 also here. If you multiply here, means what you got? 3 to the power 2, 3 square, 2 into 17 and 73. If you multiply, you will get 22266. This you will get the LCM. You will get this LCM. Now we have to verify this. How can we verify? We have to verify the formula using SCF. You have to use the formula SCF into LCM is equal to product of given two numbers. SCF you got already in this question. What is SCF you got? 9. What you have? 9 into 22266, and product of given two number. What is the given two number we had? We had 306 and 306 and 657. Correct? 657. If you multiply, what you will get? You will get same number. What you will get better here? If you multiply, you will get 2,220,394. Correct? And same thing you will get here also. 20 lakh 394. 2 lakh. Correct? So this is verified. What you can say? This is verified. Correct? This we have the verification. Now we are coming the question number 4. What is the question 4 we have? Question 4, let me check 1 minute. Question we have here, sorry, it is to get disturbed. Check whether 6 and 6 to the power n can end with the digit 5 for any natural number and natural number n. No. What you can say for this question? Check whether 6 n can end with the digit 5 for any natural number n. 6 to the power n. So what you can say, 6 to the power n means what you can say it is, 1 minute, here we have, yeah. You can say it is no. Why? Because unit digit of 6n is always 6. So unit digit of 6n. 6n means what you can say, 6 to the power n is always 6. Suppose here, if you do 6 to the power n, if you have 6 to the power 1, what will end with? 6 only. Now if you say 6 to the power 2, if in place of n, if I put 2, what you can, 6 into 6, what will get? 63. If you, in place of 3, if you put, what will get? 6 into 6, what will get better here? Suppose 36, 6 into 6 into 6, what you will get? 36 into 6. If you multiply, you will get 6 is a 36, 3. 6 is a 36, 3, 6 3 is a 18, and 3 21. So you see here, whatever the n value I put as a 1, 2, 3, what is the after multiplication? What you are getting? We are getting always 6. So what you can say, unit digit of 6 and is always unit digit. You see, this is, we have no unit digit, means first place. unit. So what you can say? Unit digits. What should be the answer? Unit digit of. So what you can say? No. We can say it is no units. Sorry, unit digit of. Unit digit of 6. 6 to the power n is always 6. So this is the first solution for fourth question. Correct. So this is the end for the exercise 1.1 for NCRT book. So we will have another video for next exercise. Thanks for watching. If you have any doubt or if you have anything, please write in my comments into comment section. Thank you.